Hi, welcome to the FreeBSD channel. So it's been a while ever since I posted any video episodes in this channel. I was quite busy with some client work, and also I was actively posting some videos that includes certain topics of FreeBSD. Especially I was doing some comparative analysis of FreeBSD network stack versus Linux network stack, and I was posting them in my the Linux channel. And also I was doing some investigation of OpenZFS or ZFS stack in FreeBSD. That includes especially FreeNAS and as well OpenZFS stack offering within Ubuntu server. So I was actively posting over there, but again I thought it is good if I segregate and try to precipitate any episodes or video topics of FreeBSD in the FreeBSD channel, so that it can be more refined and it will be apt, so that FreeBSD enthusiasts and as well as developers can subscribe to this channel and then can start watching these videos and also follow these topics covered. So long back, as you have seen, I have covered a couple of episodes on networking subsystem, FreeBSD networking subsystem, and I have done a very quick code walk, and I have shown few APIs and also few data structures. And as a part of that, I have also mentioned some kind of comparative analysis between FreeBSD sources versus Linux kernel sources, because I have also discovered there are some FreeBSD contributors who are been into Linux kernel development, and then they have moved towards FreeBSD development and stuff. So I feel this will help in case if they are into Linux and then they want to hop on into FreeBSD development, so that this gives a sort of a platform to migrate, and also they get used with that sort of flow. So you can see here I have done this table so that it kind of compares. In the case of Linux, you have this net device data structure to hold the port information of your networking ports in the Linux kernel space. And similarly in the FreeBSD you have this if var.h, in that you have this struct ifnet data structure. So this holds that port information, and there are various other structures which are linked to this struct ifnet. Okay, so that's what. And down the line you can see the network packet data structure in the case of Linux is skbuff data structure. In the case of FreeBSD it is mbuff data structure, and you have various other files to contain the APIs to support the data structure. So it's a quick recap of the same in case you are watching this after a long time. So apart from that, in the case of v4 stack in the Linux kernel, you have it in net IPv4, whereas in the case of FreeBSD it is in sys folder. Within the sys folder it is in netinet. So this is a little bit confusing if you are coming from that background, because in Linux what they have done is they have put entire stuff of networking within that net folder. So it is quite easy to go through. You have this core modules in the core directory and any specific stack level modules in those corresponding directories. In the case of FreeBSD it is kind of dispersed here and there. Okay, so you can clearly see in this case it is in sys folder, but in the case of IPv4 it is in this sys netinet and stuff like that. But if you go to the sources, there are also couple of things. There are also many things you can find it under this sys net folder as well. So we are inside the sys net folder. There are some files over there, and then you have the sys netinet folder and stuff. So it is little bit different. So if you are coming from that background, maybe this table will help you. So I may update this table down the line, so that we can also have we can also cover this other data structures, important data structures like v4 header as well as TCP header, UDP header and stuff like that. So this is what we discuss in this episode, that in the v4 head stack of FreeBSD we can discuss various modules and as well as its core data structures which constitute an full-fledged TCP IP stack within FreeBSD. So that way, if you see here, you have this ip.h, it is in this sys netinet ip.h file. So you have this entire struct IP. So this is your IP header of this FreeBSD. So using this you can do a typecast, and then you can parse a packet, incoming packets, and the packet bytes may be inside mbuf and such packet data structures. You can parse the same, and then you can get access to that IP header. So other than that, in the case of TCP, it is in this header file. It is tcp.h. You can see here you have this TCP header. In the case of UDP, it is in udp.h, again in the same folder. So entire IPv4 stack is inside the same. And in the case of v6, it is inside netinet 6. So you can see here, just like Linux, you have this IP input .c and IP output.c, and you have various APIs to support the same RX and TX path of a network stack. There is a subtle difference. In the case of Linux, always you find these header files inside that include the folder hierarchy. In the case of FreeBSD, it is sort of mixed up. But having said so, FreeBSD is a sort of highly tuned, and also it is sort of lightweight, so you may get a superior performance, because Linux have lot of features by this time, and it is getting bloated every day, and it is feature rich. At the same time, when you think about mundane networking, it may be little bit bloated by this point of time. So this is a sort of advantage when it comes to FreeBSD. But having said so, again it boils down how the kernel is tuned up and how the overall operating system is tuned up. So that's where the performance also it matters. So this is something I have done an iPerf test between a FreeBSD system versus a Linux system, and these are various things I have discussed in few episodes over here. So that is something we can't conclusively tell just because your stack is lightweight it is going to have a good performance. Eventually it is all about how well the overall kernel is fine-tuned. In the case of Linux, it again depends how a Linux kernel is fine-tuned for a specific desktop use versus a Linux server use, or some type of embedded SoC, or it is some type of Linux based OpenWRT Wi-Fi router or something like that. So it really boils down to that, whether it's an HPC or it is meant for some IoT application. So the kernel tune-up really it matters. So sometimes they do a tune-up in a different way for HPC like applications, because it has to handle bulk amount of data, several gigabits per second, versus in the case of IoT, sometimes it's just, if you use LoRa or something, it's just few bytes or kilobytes per second still, okay, because it's a long distance LAN networks, long range, long distance LAN networks. So speed is not a factor over there, because you are focusing in terms of long range. That way, if you hop onto the Linux kernel source, you can find the equivalent header file somewhere in include Linux path. Something over here you can find ip.h, something like this. You should always understand, if you are into Linux development, you should understand the entire stuff what you are getting in Linux. It's coming from that aspect. It is coming from the BSD aspect. It is not something that Linux has borrowed or something else is borrowing a Linux stack. So when it comes to networking, it is borrowed from over there. So when you see the FreeBSD, you can find that entire untouched part of ancient code, which is highly tested, and it is very reliable, and it is having that roots. Okay, that's what. So if you see here, you have this ip.h, and you can also find tcp.h over here, and you can see the difference here, the hierarchy of these files. udp.h, you can see here the hierarchy is a bit different. It is in include Linux, and then you have these header files, the main data structures, and I suppose even here you should find this skbuff as well. skbuff.h is skbuff as well, and as well as this net_device. Yeah, something like that. So you should have all of them, all these header files over here, which each one may constitute an important data structure. So that way, if you hop on, you can find its IP header over here, and you can go to this struct IP header, and we see, yes, it is under this UAPI folder. It is not include Linux, I'm sorry. So it is under this UAPI. Earlier I suppose it was in a different hierarchy if you go back to 2.x kernel or something, but later they have shifted. So why I am taking Linux as an example is it is easy to differentiate, so that when you see an operating system like FreeBSD, you can compare how these things are architected, and this will make you to understand as well as remember quite easily. So if you are starting directly from FreeBSD, there is nothing wrong also to go through a Linux kernel source and see that contrasting differences, at the same time grasp whatever it is having being done in FreeBSD, and at the same time keep the Linux as a sort of a background check or a reference. Okay, so that's why I'm just showing both the things, so that you can get that sort of perspective. So you can find the IP header here, and I suppose it is in this folder. You should able to find this TCP and UDP. So tcp.h, we search. Yeah, you can see here it is under this UDP UAPI Linux, and UDP.h, and under this hierarchy you should able to find this struct TCP header, and in the case of UDP you should able to find struct UDP header. So they have done the changes, and Linux always time to time, if you go through the same sources, they may do some type of reorganization of these sources quite often. You won't find this type of reorganization often happening in other platforms. Okay, just when you compare Linux versus something like FreeBSD. That way, if you see when you traverse the code in IP input and IP output, you should able to find lot of such references. You can see here they use this struct IP, and they need this data structure whenever they are doing some type of parsing of these headers, and in the case of input, they may do some type of defragmenting those packets, whatever packets come. So if they are fragmented, they need to defragment, and again you need to do parsing of IP headers to check whether defrag is required, things like that. So you can see in the case of IP forward, they are using that same, and in the case of various instances, you can find it's being used. So in the case of IP output, they may do they may use at various instances, and as a part of IP output, again sometimes they need to fragment, as you can see here. Sometimes they need to fragment that IPv4 packet, then they may use this kind of construct. In the case of Linux, again similar thing happens. If you find IP input.c in the net IPv4 folder, again you have this fragmentation, defragmentation stuff happens. So anytime you have the TX path, you need to fragment the packets. Anytime you have the RX path, you need to defragment the packets, in case if they are fragmented. Okay, they are v4 fragmented packets. So that's what it is. So although the implementation changes and the code changes, you should always have that RFC as the reference. So end implementation or the goal is going to be the same, and it is going to be interoperable. So when you have any FreeBSD system, and when you have a Linux system, and when you establish a TCP session, UDP connection, UDP link or anything like that, both should interoperably both should have that interoperability. So both should work seamless. You should not able to find whether it is FreeBSD, Linux or Windows in the remote system. So that's the main objective. So no matter how the code changes, it should work, because end of the day it's a standard IPv4 stack, and it should follow those standards and the RFCs and all that guidelines. Okay, so that's what you have, this type of a code. And when you hop on to something like TCP modules like this TCP input and other stuff, you should able to find struct TCP getting used. Okay, yep, you can see here you have this TCP header, you can see here. So the struct TCP header is getting used here. as one can understand. So you can see here at various places it uses the same, and similarly if you hop onto this UDP modules, you should able to find UDP header getting used. So this is let's just check UDP header. Yeah, you can see here this contains various references of that struct. So this is a sort of a way you do a code walk, and unfortunately when you compare something like Linux, see Linux have extensive documentation. Of course FreeBSD they try to give some documentation, but Linux have lot of extensive documentation. When it comes to a network stack, there are a lot of good documentation available, like you can see here. You have this type of network flow API map flow charts, and as well as you have this this kernel network stack and other stuff. So this flow chart is quite interesting from Linux Foundation. You can see here they have provided an entire API hierarchy, and you can see from which API how it is linked, and some are decision making APIs they have put in that diamond, as one can understand, and some are meant to do a specific task and stuff. Okay, any callbacks and stuff, everything they have defined in this kernel map. Similarly, if you come here, you can find so much extensive documentation of again this type of high level design diagrams. So these are like high level block diagrams. You can see even they have plotted the API names, the most important API names of that IP input and IP output and stuff. But this will differ in FreeBSD. But having said that, you may not get this type of extensive documentation quite easily in the case of FreeBSD. So that's the attempt. I thought to have an exclusive channel so that I can go in depth as much as possible, not just network stack alone. It can be any components in FreeBSD and anything related with the FreeBSD. I thought of covering in that different channel. But having said that, meanwhile down the line I posted few episodes in the Linux channel, but again I thought it will be it will make sense to post FreeBSD topics on FreeBSD channel. So that's what. So hope you guys loved this video. If you have anything to discuss, be in touch via mail. So down the line I may post a couple of more episodes and also some type of live sessions, so that it will get more interesting and we can see these things in action, just like the way I have done it for Linux channel as well. Because just talking theories, it doesn't make any sense. We need to see the code in the action. We should able to trigger any debug points, and we can able to insert and do some live code analysis and get much clearer picture of what each module is doing, and also get some type of conceptual idea of the entire big picture. So I may do some type of HLD diagrams in the future, because as I said, you get quite easily in the case of Linux, but unfortunately in FreeBSD it is quite very hard, and if you are a beginner, you need to start all the way and you need to do this type of manual code walk, and then you need to figure it out things by yourself, and it takes a lot of time. Instead, it is a good to cut short some amount of time. As much documentation you get, it is going to save your time, so that you don't spend a lot of time in some areas which is not required. You see the picture, and then you get that entire big picture, and then you can later go in depth as per your convenience, as per your free time, and then you can explore those internal subsystems, or else APIs which constitutes a specific module. So if you have anything to discuss, be in touch via mail, and also you can post your feedback or queries in YouTube comments. Thanks a lot for joining me. Stay tuned. Have a nice day. Bye bye.